Hey y'all, today we are going to do Unit 4, Day 3 notes, and we're going to be looking at end behavior of a polynomial equation. So I know we've already looked at this a little bit when you look at a graph, what is the end behavior? But today what we're going to do is look at an equation and figure out what the end behavior is going to be of a graph. So we're going to kind of do it backwards from what you have done in the past. So let's think about what we know. All right, y equals x squared. That's a quadratic. It's a monomial like we talked about the other day, but this quadratic makes a parabola. We've done a lot of stuff with graphing parabolas, so we should be very comfortable with that. And if I look at the ends of each of these parabolas, I can see that this one should really have an arrow on it, and it's going towards infinity. And this one should really have an arrow on it as well, because it is also going towards infinity. So as x goes towards infinity, as we go to the right on the x-axis, then y is heading towards infinity. This arrow tells me it's going up. So as I go to the right, I'm also going up. So I'm going to put infinity in this blank. All right, now this one, as x approaches negative infinity. So that means from 0, I'm heading toward the left, which is backwards from how we normally read a graph, but I'm going to start at 0 and I'm going to head towards the left because this says I'm going towards negative infinity. And again, I notice that the graph is going up. So y is going towards positive infinity. Well, turns out no matter what even exponent you have, 2, 4, 6, 8, it doesn't even matter. Whatever even exponent you have, you're going to have this same behavior on the ends. Now, what happens here in the middle is going to change depending on if it's x squared or x to the fourth or how many terms you have, but what's going to happen on the end will never change. So for all functions, when the highest exponent is even, and now look at the leading coefficient. We got to fill in that second blank. The understood coefficient right here is a positive 1. So when I have a positive 1, oh, you can't even see that. Let me put it over here. Positive 1. So when you have a positive leading coefficient, you guys know that the parabola opens upward. We've already looked at that as we did our graphing. So I'm going to put right here that the leading coefficient is positive. So no matter, again, no matter how high that even exponent happens to be, no matter how crazy that positive coefficient is, as long as it's even and positive, it's going to go up just like a parabola, just like what you're already used to. And so it's going to be positive infinity on both of them. All right, now what happens when we put a negative right here? Well, you guys know that negative is a reflection across the x-axis. It's basically going to turn the parabola over and make it point down. Now, again, I ought to have an arrow right here. So as x goes towards positive infinity, as x goes to the right, look what's happening on y. Y is going down towards negative infinity. So that's what's going to go in this first blank, negative infinity. All right, now look at this one. As x goes towards negative infinity, so starting at 0, negative infinity is to the left. So x is going to be moving this way. And look what's happening to my graph. My graph is going down. Ought to be an arrow right there because it's heading towards negative infinity. So that's what's going to go in that blank. So again, just like this one works for all even functions with a positive leading coefficient, I'm sorry, not even function, even exponent. For every even exponent with the highest degree is even and my leading coefficient is negative, it's going to be just like the ends of this parabola. Again, in the middle, all kind of things could be different, but on the ends, it's going to be the same. So when the highest exponent is even and the leading coefficient is negative, that's what's going to go in those two blanks. Now you guys have already learned parabolas. You already know that positive x squared opens up and negative x squared opens down. So all you have to do is remember that every one that has a highest exponent that is even works exactly the same way as the x squared that you have already learned and practiced with. All right, now yesterday Miss Idstein did some that were cubic. So let's look at what happens with those. X to the third. This is your typical, this is your parent graph. And I should have an arrow, goes on and on forever this way. So as x goes to positive infinity, as x goes to the right, I can see that my graph is going up towards positive infinity. So that's what's going to go in the blank right here. And on this side, as x approaches negative infinity, as x goes to the left, Well, there ought to be an arrow down there because this one is going towards negative infinity. So that's what's going to go in that blank. I'm going to put negative infinity here. So as x moves to the right, y is moving up. That's what this line means. And this one says as x is going to the left, as x is going towards negative infinity, y is going down. Y is going towards negative infinity. Okay, now when we looked at this one with x squared, we said, okay, this works for all of the functions whose highest exponent is even. Well, same kind of thing here. This is going to work for all of the functions whose highest exponent is odd. And the leading coefficient, you guys know there's an understood one right here. One is positive, so that leading coefficient is positive. That's what goes in the second blank. Okay, let's look at this one. So when I have a negative right there, again, you guys already learned this. When I have a negative, it flips over the x-axis. It's a reflection. So what's going to happen is that what used to be up is now down, and what used to be down is now up. So as x approaches positive infinity, as x goes to the right, what's happening to my function? Well, it's going down. It's heading towards negative infinity. I'll put the arrow on there so you guys can see that it's going towards negative infinity. And as x approaches negative infinity, as x goes to the left, what's happening here? Well, there should be an arrow right there because this is going towards positive infinity. So I'll put that in that blank. So as x approaches positive infinity, as x moves to the right, y is going down. Y is going towards negative infinity. And as x goes to the left, y is going up. Y is going towards positive infinity. Well, just like the other ones, this happens to work for all the functions when the highest exponent is odd and the leading coefficient this time is negative. So my I didn't show up, is negative. So if you guys can remember those pictures in your mind, remember the parabola for x squared and negative x squared, and remember this squiggly kind of snake shape for positive x to the third and negative x to the third, then turns out you can answer any end behavior question that a teacher might ask you. So here's an example. All right, let's look at this one. 3x to the 6th minus 4x to the 5th minus 3x squared plus 8x minus 7. Okay, so let's go back and review for just a second. What is the name of this particular thing based on its number of terms? Well, I count 1, 2, 3, 4, 5 terms. 5 is more than 4, so I'm just going to call this a polynomial. And the highest degree is 6. So this is a degree 6 polynomial. We don't have a special name that we have to memorize for degree 6, but just so you know what it is. Okay, so the highest one we just identified is this one. So when we talk about end behavior, the only one we need to be concerned with is that one. All these other ones we're not even going to look at. I'm just going to scratch them out so they don't get in our way, and we're going to focus on that first one. Okay, so I notice that the highest exponent is even, so that tells me I'm thinking like a parabola, and the leading coefficient is positive, so my parabola is going up. Now, I don't really necessarily know what's going to happen here in the middle. Maybe it's going to go up and down a couple times, maybe it's going to flatten out. It doesn't even matter because this is just asking us about end behavior. So it's asking us what happens on the ends. Well, I can see that this one is going up and this one is going up as well. So as x approaches positive infinity, as x goes to the right, y is going up. It's going toward positive infinity as well. As x goes to the left, as x approaches negative infinity, y is going up, y is going towards positive infinity. So you guys can see positive even, I've got positive infinity on both of them. All right, let's do another one. Let's look at this one. So this one is not in standard form. Remember we said standard form is from the highest exponent to the lowest exponent. Well, this one's not in standard form, but we can still identify it. Let's classify it based on its number of terms. Well, I see 1, 2, 3 terms. So this one is a trinomial. And the highest exponent, where's the highest exponent? Well, it's right here in the center. So this one has a highest exponent of 3. This one is a cubic function. I have a cubic trinomial. Now, just like the last one, when I'm looking at end behavior, the only one I need to think about is the highest. So I'm going to scratch those other ones out, get them out of our way. And I look at this one is odd. So this one is going to make me think of x to the third. And that negative tells me it's been flipped over the x-axis. So something like this. Well, this one is going down. That's negative infinity. This one's going up. That's positive infinity. So as x moves to the right, as I move to the right on this graph, which way is y going? Y is going down. So I'm going to put negative infinity in the blank. And as x approaches negative infinity, as x goes to the left, which way is y going? Well, y is going up. So I'm going to put positive infinity there. All right, let's try another one. Okay, this one, look, 4, 3, 2, no x. This one's in standard form. It's from the highest to the smallest. All right, which one of these do we need to look at to determine the end behavior? Right, we only need to consider the highest one. So I'm going to circle this one, and I'm going to scratch out all these other ones because they do not help us with end behavior. Okay, so my exponent, let's look at the exponent first. My exponent is 4. 4 is an even number, so I'm thinking about parabolas, and it's negative, so I want to do a reflection across the y-axis, I'm sorry, across the x-axis, and it's going to be like that. So this one is going down. This one is also going down. It's going to be approaching negative infinity both directions. So when x goes to the right, that's this one. It's approaching negative infinity. Y is going down. And as x goes to the left, that's this one. So I'm going to look over here on the left. And again, I see that y is going down. So that's going to be negative infinity. So the answer for both of those, negative infinity. All right, last one. So look at this one. Exponent of 1, exponent of 2, exponent of 5, 0. The highest one is here. This one is not in standard form. They kind of hid it from us. So the highest exponent is here in the center. Okay, I noticed that this one is positive, so I'm thinking that squiggly x to the third shape. I'm sorry, that's odd. Squiggly x to the third shape. And this one is positive, which means it has not been flipped. It starts down and ends up. Okay, so if it starts down, that arrow is pointing down. Ends up, that arrow is pointing up. Okay, so as x goes towards positive infinity, as x goes to the right, that's this direction. So I want to look at this one, and it's going to be positive infinity. As x approaches negative infinity, as x goes to the left, okay, that's going to be this one, and it's going down. So I'm going to put negative infinity in that blank, and that's going to be the answer to that one. All right, a couple things I want y'all to notice to help keep this straight in your head. Look back at the ones that are even. Do you notice that both ends go the same? So when it's positive, they both are going up, infinity, infinity. When it's negative, they're both going down, negative infinity, negative infinity. So when it's even, they both go the same. But when it's odd, do you notice that they're opposites of one another? Right? So I taught my class last semester, odd opposites. They go opposite one another when they're odd. So when it's positive, again, the positive one is going up. When it's negative, the negative one is going down. That, look, when it's positive, the positive one is going up. When it's negative, this one is going down. The positive side is going down. And it's exactly the same with this one. Positive up. The negative one, the positive side, is going down. What changes is that it goes the opposite direction the other way. So maybe that can help you keep it straight in your mind about which one is which one. But I really want y'all to realize that if you already know what the parabola graph looks like, and I know you do, you can use that to get every even one. And if you remember the x to the third graph from yesterday, you can use that one to get every odd one.